address. So IP address earlier, like we used to have a lot of different versions. So we have classification versions as known as classful method for IP classification. Then if we have classful, then we will have classless. Okay, then these are the two things. Then we have versions also. So we have IPv4 and then we have IPv6. So this is V6 version, this is V4 version. So V4 version we'll talk about, V6 version we'll talk about. V4 and 6 represent the bytes. Okay, so earlier we used to have IPv4, means there were less number of hosts, but now if you see, everyone, even if your mobile is there, if your laptop is there, anything requires an IP address to get the recognition in a network, right? When you are there, you know, okay, this is your roll number and this is a person which belongs to this particular college. Then if someone knows your college and your roll number, they can directly identify you. Similarly, any host which is getting connected to the network, okay, this World Wide Web, www, so it needs to be recognized, right? So how can they be recognized? They can recognize by the IP address. So every host get an IP address, and this is how they get recognized in this web. Now, as we were going ahead and ahead, you can see that everything, even now, what you know, we have IoT, right? Internet of Things. And there are small things which now want to have an IP address. So the demand of IP address has exponentially grown high. Therefore, we had to shift from IPv4 to IPv6, which means we will be using 6 bytes instead of using 4 bytes. Okay. Again, here we have actually 32 bits, which has been divided into 8:8:8:8, right? So this is how it is represented. And here you will be having 2 more. Okay. So this is what is the difference between IPv6, IPv4 and V6. And through the entire like discussion, we'll be studying about IPv4 only. IP, and like when you it's like mostly the interviewers and everywhere you will be asked about IPv4. Actually, in practice, both are being used. So there is a conversion process and everything which happens in the backend. So that we are not going to study. That's like not the scope from we have to study about computer networks, but this is how it works. So if you're able to understand IPv4, the same concept applies in IPv6. But yeah, the fields, the other change, there are other minute changes which happens in IPv6. So this is there. Now we have classful method and we have classless methods. So in classful methods, we start dividing IP, this 8 is to like 8:8:8:8 into certain parts, right? So 8 is what? It is 8 bits. Okay, so we have 8 bits. Similarly, we have another 8 bits, then another 8 bits, and another 8 bits. So what we do in classful is we take certain number of bits and then we say, okay, if this particular IP, if the IP address is having the starting bit as, let's say, or if the particular IP address is having this particular bit, then we say, okay, this is going to be in class A. So let's say you have 0 in the starting. Okay, so if you have 0 in the starting, we say this is class A. Okay, then if you have 1 0, then we say it is class B. The next would be what? 1 1 0. This is known as class C. And then it will be having, next would be 11110. This is known as class D. So till class D we have also like there are other divisions as well, but we'll focus on these 4 classes: class A, class B, class C, class D. Now, if you again go ahead and how we came across this particular way, 0, 1, 0, 1, 1, 0, 11110. So if you see, if I say that you have to go and think how binary system works. Okay, so if I say you, there are 3 bits So how many numbers you can represent? It is 2 to the power 3, which is 8. So it is like 0, 0, 0, 0, 1, 1, 0, 1, 1. And this would be 0. So if you see, this can be divided into 0. And similarly, we can have ones. So 0, 0, 0, 1, 1, 0, and 1, 1, right? So if you take the first particular bit, this can be directly divided into two parts. So similarly, what we did here is, so we had how many bits? We had 32 bits. Let me go down a bit. Yeah. How many bits we had? We had 32 bits. Okay. And now in 32 bits, what we did was we kept first 0 as constant, then we were left with 2 to the power 31, right? 2 to the power 31 number of combinations that we can have, because the total length of IP address was 4 bytes. That was 32 bits. So ultimately we took one bit and we said that, okay, this is class A. Okay. Now we were left with 2 to the power 31 having 1 in the starting. What we did was we again divided the second part, what was left after class A, into two parts. So if you see, this was having 1 as the first bit, right? So 1 would be automatically present. 1 will be automatically present. Now if we have to make another class, we have to take 0 after it. So we took 0. So this was known as class B. And how many bits are left? 2 to the power 30. Did you get it? Now again, if we have, what is the downward, the second half, it would be 1, 1, 1, 1, right? Again, what we are doing, we are dividing into two parts, means we are dividing this into two parts. So what will happen is this 1, 1 would be remaining constant throughout. But what will change? The third bit. So here we'll have 0 and here we'll have 1. So this is 2 to the power 29 and this is class C. And again, what you can go ahead with, you can divide this again into class D. So it will be having 1, 1, 1, right? And then 0, 2 to the power 28. And here we'll be having 2 to the power 28 and this will be 4 ones, right? 2 to the power 28. And this is class D. And this is known as class E. And after class E, we don't have divisions. So we have class A, class B, class C, class D. And our main focus would be actually class A, class B, class C. Fine, we can, like, class C and class E won't be even asked to you. And there are not a lot of discussions which is there in the books. So the primary discussion would be class A, class B, class C. What I have taught you till now is the classful division of IP addresses. There's another type of division of IP addresses, which is classless division, which we'll see later. Okay, so this is class A, then we have class B, we have class C, we have class D. Now, if you see class A, if you see the IP address of class A type, so let me write class A. So if you see the class A, it is having 32 bits. Every IP address is of 32 bits. Now, this particular IP address, which would be divided into two parts. Okay, the IP address is divided into two parts, which is known as network ID and another is host ID. So in the starting of the discussion, we started with that IP address can be used to identify host as well as network, right? We were saying that IP address would be able to identify host as well as network. So how it is possible? So actually what happens is that any IP address which you have is actually made of two parts. Okay, one part is known as network ID and the other part is known as the host ID. This is making sense. Again, we were having IP address, we were having port number. Port number recognizes process. IP address was able to recognize the host. Now, in the internet, there are a lot of networks. Geo, this, there are private networks. Let me say I am going to establish a big organization. Now what I will do, I will have that, okay, my all the hosts which is present in my organization should have starting common IP addresses. So there would be a bunch of addresses which will be allocated to me, and therefore I need to identify the network, and then I need to identify which host, because if you see any network, there will be a lot of hosts present, right, in this network. If you see your college network, there are a lot of computers which are being present, lot of hosts which are present. Now inside a network, you have to recognize a host. Therefore the IP address is divided into two parts. One is known as the network ID, other is known as the host ID, which actually recognizes, okay, this network, inside this network, this particular host. And then you have a port number which I said, okay, this is the host, now this is the process inside this particular host. So this is how the thing works. I like this computer networks is really intuitive. So if you start feeling about how the things are actually working in real world, you'll start enjoying computer networks. So again, let's get back to the division. So we have class A, we have 32 bits. Now we know that in class A, the condition is that this particular first bit is fixed, which is 0. In class B, 10 is fixed. Class C, 110. Class D, 111, and class E, 4 ones. Okay, you just keep this in mind. So here, what is fixed? The first bit, if you talk about, 0 is fixed. Okay, this is fixed. So the rest 8 bits. So this is the, I am dividing into 8 bit. Okay, 8 bit, 8 bit, 8 bit, 8 bit. The first bit of class A is filled with 0. So we are left with how many bits? 7 bits. Okay, we are left with 7 bits. Now, this 7 bit is going to represent the network ID. So if we talk about class A, so this particular division is, this part represents the network ID and this part represents the host ID. So 8 plus how much? 24, which will give you 32. Network ID, host ID, and this is IP address. This is for class A. Okay. So 0 and the rest part would be able to represent the network, and the rest are going to represent the host. Now I need a response from your end from now, that how many hosts are possible in class A? How many hosts are, let's talk about first how many networks are possible in class A. We have network ID, 8 bits constitute the network ID, 24 bits constitute the host ID. Now, how many networks are possible in class A? So it's 2 power 7, because you see we have 8 bits, and out of 8 bits, 1 bit is being occupied with having 0. So we have 2 to the power 7. So it is 128. So how many networks? 128 networks is possible in class A. Now, can you tell me how many hosts? Exactly, 2 to the power 24, which is around 16 million. Okay, so number of networks 128, number of hosts 16 million hosts. So if I have a very big company, then I will say, okay, I want a class A type of network like this. I want a class A type of IP, right? Because I have one, let's say you have one network, let's say there are 128 companies, very big organizations or companies, and how many hosts they will be able to have? 16 million hosts. You get the number, right? This is how the division is happening. So we say now, okay, this particular type of, you say, okay, 192 dot this is very common with Google like Google. So Google have actually purchased or they have reserved, don't you say, you can say they have reserved this particular network having these many hosts as their own. Okay, so if I say, okay, I want a class A ID, so how many hosts I will be able to actually have, or how many hosts I can able to connect? It is 16 million hosts. So if I'm having a very big organization, I can go ahead for class A. But the thing is, the catch is that you can have 16 million hosts. Okay, if you say, you can say you have 16 million host ID, right? You can have this many host ID, but the thing is that the number of hosts which we'll be able to have is 2 to the power 24 minus 2. This is a figure which you need to know, and this minus 2 happens for every class. We'll know why we are doing minus 2 with a later course, but you can understand, okay, if I have class A, I can have 2 to the power 24 or 16 million hosts. Minus 2 means there would be 2 IP addresses which will get wasted. Okay, and we'll be able to understand why those 2 IP addresses, actually those 2 IP addresses are reserved IP addresses, which are, let's say, if I take 0, right? So actually this is reserved. Even if I have, let's say, these 8 bits as what, 127.0.0. So if you see 127 is a valid network ID, right? Because it is falling from 0 to the power 7, right? What are the valid network ID? It will be 0, 1, 2, 3, something till 127, right? So if you have 1.0.0.0, this is a valid network ID. If we have 127.0.0.0, this is a valid IP address, right? So if you see 127, so this particular IP address having .000 in the host ID is recognized, is like reserved. Similarly, all ones are also reserved. So again, that might be confusing a bit. So let me again tell you. You have network ID. Network ID has no clauses or no minuses or something, but host ID has minuses. So whenever you have host ID, which is now here, if you see in class A, you have 24 bits, right? So in 24 bits, if all the bits are 0, okay, which will be represented as something as 0.0.0, and if all the bits are 1, so it will be represented as 256.256.256, right? 2 to the power, it is like 8 bits, 8 ones, so 8 1 is 256. So these two actually IP addresses are reserved for each network. Okay, so when you have, let's say, the network ID, let's say a network ID is 120. Network ID 120 is possible in class A? Yes or no? 120 is possible in class A or no? Yes or no? It is possible because the range is from what? It is from 1 to 127. Because 0 is already reserved, so the network ID range would be from 1 to 127. So 120 is possible. So 120 dot, they will be how many bits? 24 bits. So in 24 bits, it will start from 0.0.0, then 0.0.1, 0.0.2, and so on. It would be something like 0.256.0, and it will go, right? It will go on. I got like, yeah, 255. I'm sorry. It is 255. Yeah, so 2 to the power 8 minus 1, 255. That is the maximum number we can represent in 8-bit. So yeah, so 0.255.0, 0.255.1, and it will go on. So the last would be 255.255.255. So this is how it will go. Okay, so the last is going to be 255.255.255. So the first IP and the last IP of the network are being reserved, and these are reserved for a particular purpose, which we'll be understanding later when you'll go ahead. They are represented for broadcasting and other things. So other than that, any host which is present in the network can take up the IDs from 1 to 255.255.254. Okay, this is there. So the last would be 255.255.254, and that can be taken up by the any host which is present in class A type of network. Now the same thing, we go ahead with class B, class C, and class D. So it would be very quick, and I want a lot of answers coming out from you. So we have class B. Let's go ahead. So for class B, the division is You have 32 bits. 32 bits. We have network ID and host ID equal. So they will be how many bits? It would be 16 bits and 16 bits. And we know that in class B, what is reserved? The first 2 bits are reserved, 1, 0, right? This is there. We discussed it in the above diagram. So 1, 0. So how many host network ID is possible?
2 power 14.
Exactly, 2 to the power 14, which is actually roughly equal to 16K. And how many hosts? 2 to the power 16. Right? So 2 to the power 16, which is the IP address, IP number of IP per host. Okay, so again, if this is the IP, but if we talk about the host which is present in each network, it would be 2 to the power 16 minus 2 because 2 IP addresses are reserved. Now, a quick question to you. Number of IP addresses in class A. Can you tell me how many number of IP addresses are there in class A? We had 32 bits, right? The first bit is 0. So we are left with 2 to the power 30. We are left with 31 bits. So how many IP addresses are possible? It's 2 to the power 31, right? Then what is 2 to the power 24? It's very easy. Each network is going to have 2 to the power 24 number of IP addresses present. So the total number of IP addresses present with all the networks would be 2 to the power 7 into 2 to the power 24. Did you get it? I said that if I have a very big company, if I take one class A, I would be able to get 2 to the power 24 IP addresses. That's fine. So how many companies, other companies would be there like me? There will be 128 other companies because there are 7 bits here, right? So each company, if I multiply with the number of IP addresses that each company would get, that is 2 to the power 31. Similarly, class B, what is the maximum number of IP addresses? It would be 2 to the power 30, right? This is just simple mathematics, like how many permutations and how many what do you say? How many? They have 2 bits, 0 and 1, and you have how many places? 30 places. So how much possibilities are there? How many combinations can you make? So it's just 2 to the power 30. Let's move to class C. Now this looks quite easy. For class C, what we have 1, 1 and 0. And for class C, the division is 24:8. So 24 bits goes to network ID and 8 bits goes to host ID. So how many networks can we have in class C?
2 power 21.
Exactly, 2 to the power 21. And how many hosts? Which is around 2 millions. How many hosts?
2 power 8 minus 2.
2 power 8 minus 2, exactly. That's excellent. So we'll have some number of hosts. Now, if you just carefully observe how we went ahead. So we said that when we have class A means we have so many host IDs. Then we move to class B. We have fairly more number of networks and less number of hosts. But it was good. And then we move to class C. We have a lot of hosts, sorry, a lot of networks, and then we have fairly less number of host IDs, or we can say you have fairly less number of hosts. So this is how the division is being made of the IP addresses, so that based on your organization, how big your organization is, how small your organization is, you can do the division of the IP. Like you can choose any particular IP addresses based on the organization. You go with class A, class B, class C, and then we have class D. If we talk about class D, actually class D and class E are not actually divided, and they are actually reserved. These class D and class E are reserved and mostly used for military purposes. So you have military transmissions and everything. So they are mostly used for military purposes. We are not going to touch over there, but you can understand this. Okay, now let us actually just wrap this particular thing, whatever we have discussed so far about the IP addresses. So if we talk about, let's say I want to have, this is class A, class B, class C, and then we have number of networks, number of IP, okay, per network, okay. Then we have total number of IP, then we have total host. Okay, so someone can start popping up the answers. Class A, what is the total number of networks we have? 2 to the power 7. Okay, again, there is something which we which will cover 0.0.0.0, and the last 255.255.255.255 are again reserved. So sorry, 127.0.0.0, these are reserved. We'll talk about it. So 2 to the power 7 is fine, but they are 2 less than that. So we have 126. Class B would be having 2 to the power 14, right? Or how much? 14. Because 2 bits are being reserved for class B. It is 0 and 1. For class C, 3 bits are reserved, right? Sorry, it's 1 and 1 which are being reserved. Or you can say 1 and 0. 1 and 0 are being reserved. Here we have 1, 1, 0 which is being reserved. And here we'll be having 2 to the power 21. And number of IPs, so 8 bits are there. So we will be having 2 power 24, 2 power 16, and here we'll have 2 power 8, right? It is per network. So if we multiply these two, it will be 126 into 224, 16, and this will be 2 to the power 30, and this will be 2 power 31, right? Sorry, 29, yeah, 29, yeah. 29, this will be roughly equal to the power 31. So 31, 30, and 29, because we are reserving the bits, right? So this was how the division is. And if you talk about the total number of hosts, so the host will be actually equal to, similarly to the power 16 minus 2 to the power 8 minus 2. So this is the complete discussion about the classful way of classifying the IP addresses, which was followed. Now we have a different way, which is classless, and in class